Hello, in this lecture video I am going to be talking about density. Density is the amount of material in any given three-dimensional space, and we're talking about volume here. So for liquids, that normally is indicated by grams over milliliter, but it could also be any other unit of mass on top and any unit of volume on the bottom. For solids, that normally is grams over cubic centimeters, and sometimes that is abbreviated as cc. Now, the reason why you have a cube unit length here is solids are measured, like instance for like in this case for a rectangle, it would be length times width times height. And if you have your sides measured in in centimeters here, what happens is you multiply 3 centimeters, you actually get the cubic unit here. That could also be the same as the unit of a sphere, or like in this case, as a cylinder. So that would be the same way that you would find the volume of that. Now, why is this so important? The reason why this is important, it just tells you how much matter is in a unit volume. And it should be obvious to everyone that this is dependent upon how many atoms are in in space, as we consider them. And the unit of atoms, how many atoms there are in space, is dependent upon intermolecular interactions. So this is from one of our previous slides. So the stronger the intermolecular interaction between two atoms or two molecules in the space, the closer those atoms are in space, which means to say that there are more particles in a given space, which will give you a higher density. That is why solids are normally have high density, and liquids have middle density, and gases have the lower densities. Now, are there exceptions to this rule? Of course, but for this class purpose, we'll just kind of generalize and say that is the case. Now, water has a density of, in this case, has a density of 1 gram per milliliter or 1 gram per cubic centimeter. So that means to say that any material that has a density less than that of water will float, and so on and so forth. Now, you might be thinking to yourself, well, Abner, well, how does an aircraft carrier float on water? Okay, and why is it that, like I throw a rock, and a rock, which is definitely way smaller than, in this case, an aircraft carrier, sinks in water? Well, this is volume. This is, again, dependent upon density. So if you have lots and lots and lots and lots and lots of mass, but you also have lots and lots and lots and lots and lots of volume, well, your density can also be smaller than 1. So you just have to take that into consideration. It's not like you have 50 or 80,000 tons over 1 mil. Obviously, that is not the case for an aircraft carrier. Density is a very important mathematical relationship in conversion between volume to mass. So when you go from volume to grams or volume to cubic centimeters and vice versa, this is it. And the way you use this is called the density triangle. Is if you are, in this case, solving for density, you cover density. So you would cover, in this case, this area here. And as you can see, the mathematical operation to calculate density is mass over volume, because mass is on top of volume. If I, in this case, if I am trying to calculate the mass, you can see that density is across from volume, so you just multiply density times volume. And obviously the last one, if I'm calculating for volume, it should be straightforward. As you can see, it's mass divided by the density. So this is actually how you use this density triangle. And again, this density triangle is actually, or the density pyramid is actually also in your exam reference sheet. So we'll go straight forward to some mathematical examples. So here's the first question, and I probably should move this so that you don't bug down. What is the density of a liquid as the volume of this and the mass of that? So again, from the density pyramid, you should understand that density is always mass over volume. And this is mass over, and FYI again, you can divide any unit of mass over any unit of volume. So what is the answer to this? We do the math. We do 5.6 grams over 12.3 mils. This is the answer. And again, we are now applying significant figures again. In this case, you have 2 given numbers. You have 3 significant figures here. You have 2 significant figures there. So therefore, your answer has to be has to match the least number of significant figures, which is 2, and that's why it's 0.46. Why is it 0.46? First significant, not significant, first significant figure, second significant figure. This 5, we look to the number to the right, there's a number 5, it's bigger than, it's 5 or greater. This number gets bumped up to 6. And obviously the units do not cancel, G does not cancel milliliters, so this remains the same. This is a little bit more of a difficult problem. What is the density of a solid cube that have sides of 1.2 inches and a mass of 0.55 ounce? And now there's a further, in this case, further requirement, report the density in grams per cubic centimeters. So we need, that means to say that this mass, 0.55 ounce, has to be converted into grams. This unit of length, inches, has to be converted into centimeters. But here's the deal. A cube, if you remember your basic geometry, has 3 equal sides. So that means to say that the 3 sides, length, width times height, are all 1.2 inches. I hope that makes sense to you. So a cube has 3 equal sides. If this was a sphere, I would give you the formula for the volume of a sphere. If this was a cylinder, I would give you the formula for, in this case, a cylinder. If this was a triangular, this is a conical triangle, in this case, a conical like material, I would give you the, in this case, for the formula for the volume of a conical triangle. Okay, so long math, but the basic thing here is we're converting this inches into centimeters first. So again, this is from unit of length, 1.2 inches times 0.3937 centimeters. Again, this unit has to be the same unit on the bottom. The unit that we want has to be on top. So we need 2 significant figures. Why 2 significant figures there? That is the answer. So each side of this cube has a length of 0.47 centimeters. Now we're going to multiply all 3 sides together because the volume of a cube is length times width times height, which happens to be the same. So we multiply 0.47 times 0.47 times 0.47. If you have a calculator, you just take 0.47 raised to the 3rd power. This gives you this volume of the cube, 0.10 cubic centimeters, or cc. Why do I have 2 significant figures? 2 significant figures. So right now we have the unit of volume on the bottom. So we have figured out this unit. Now we need to change 0.55 ounce into grams. That's actually a little bit more straightforward. Ounce, grams on top, because we need grams. Multiply this 2 numbers, divide by 1. We have this number, but obviously we need to have 2 significant figures, so we round up to 16. So now at this point, we have the unit of mass, we have a unit of volume. What do we do next? Well, density is always mass divided by volume. And here we go. And the answer in this case is 16 divided by 0.10 is 160 grams per cubic centimeter. So this is the density of this solid cube. Now here, folks, why do I have 160 again? The reason why I have 160 is because this only requires 2 significant figures. The 0, the trailing 0, because there's no decimal point, is not significant. Now we're gonna go, so we have measured the density of a volume, of a liquid and a solid cube. Now we're gonna be converting from, in this case, volume from mass and density. So again, if you go back to your density pyramid, the way that you actually calculate for volume, in this case, is you take the mass and you divide it by the density. So this is actually this divided by the density. Now what I have done here is I actually used dimensional analysis. So this can be expressed as 7.8 grams over 1 cubic centimeters. So I flip it, because the reason why I flipped it, folks, is because I need to cancel the G and I need to have cm to the 3rd power, cubic centimeters, right? So 12 times 1 divided by 7.8 is this huge number. And again, we need to round to 2 significant figures. Now you might be saying, Abner, I see 3 there. Good. But you guys see the number of significant figures for the density? It's 2. So the answer has to be in 2 significant figures. And again, first significant figure, second significant figure, look at the number to the right, less than 5, remains the same, 1.5 cubic centimeters. Now we're going from, in this case, we're trying to find the mass of a liquid that has this volume and this density. If this was 12 divided by the density, guess what? This is now volume times density. And again, you know that it's volume times density if you use the density pyramid, but you can also use dimensional analysis here. Why? Again, note that this is 0.97 grams divided by 1 mil. So I can use this whole unit by itself. I don't need to do any flipping. The reason why I don't need to flip is because the mils, the unit that's given, and the unit on the underneath in the denominator is the same, and I'm going to be left with the unit that I want, which is grams. And again, mass. 22.5 times 0.97, it's this number. Again, we need to have, in this case, significant figures here, and I messed up here. This should be 23 grams. So this is actually an error. Okay, so we need to round to 2 significant figures, 3 significant figures, 2 significant figures. This should be 23 grams, right? First significant figure, second significant figure, look to the number to the right, 23. So the main take point here, everyone, is to remember, how to use the density pyramid. If you know how to use the density pyramid here, you should be all set, okay? And I don't know why I'm flipping through all of these things, so this is the main key for this density calculations. And again, if you're looking for density, you cover density, that's just mass over volume, and so on and so forth. This is going to be important in the succeeding chapters, so make sure that you work through some of these problems.